Hey guys, in this video we're going to talk about evaluating algebraic expressions. Okay, so what does it mean to evaluate algebraic expressions? So in the last video we talked about the different parts of an algebraic expression. We talked about coefficients, we talked about terms, and we talked about operators, as well as constants. So evaluating an algebraic expression is just the process of substituting or replacing a variable with a number and then computing the value of the expression by order of operations. Okay, so let's do some examples of this. So our first example here is evaluate this expression, right? 3x plus 5 is an algebraic expression when x equals 4. So all that means is that we're going to plug in 4 in anywhere we see an x, right? It says this statement right here, x equals 4, says x is the same thing as 4, all right? So instead of the x, we can put 4 there. And we get 3. Instead of x, I'm putting in a 4, and then everything else carries down. So 3 times 4 plus 5. Now we use order of operations, so we do multiplication first. 3 times 4 is going to give us 12, and then carry down the plus. And finally, we'll do the addition to get 17 as our final answer. So we just evaluated 3x plus 5 when x equals 4. Now it's important to know that we can evaluate with multiple variables as well. And so we're going to do some examples of those in a few more slides. Let's practice where we're evaluating with one variable. So here we have an expression 5y squared plus 7y plus 3, and we want to evaluate it when y is equal to negative 4. So all that means is anywhere we see a y, we can replace it with negative 4 because they mean the same thing. So right here I see a y, and right here I see a y. So I'm going to rewrite this with my parentheses open so I know to substitute that y in there. All right, so I'm just literally bringing everything down except for the y. And in replacement of the y, I'm going to put negative 4. And now I'm going to apply order of operations. So order of operations says that we need to do the exponent first, right? Because everything else is multiplication. This is multiplication right here, and then we have multiplication right here, and then we have addition here and addition here. So the first thing that we need to do by PEMDAS is our exponents. So negative 4 squared is just negative 4 times negative 4, which is a positive 16. So I'm going to put a positive 16 in its place and carry everything else down. Okay, so negative 4 squared became positive 16. Now, the next thing in PEMDAS, all right, so we did exponents. The next thing is multiplication. So I want to multiply this, and 5 times 16 is going to give us 80. So that becomes 80 plus carries down. 7 times a negative 4 is a negative 28 plus 3. And if you remember from our integers unit, when we had a plus and a minus right next to each other, those guys became a minus. So I'm going to just change that to a minus. And now I can evaluate from left to right. 80 minus 28 is 52, plus 3 is 55, and that is our final answer. Okay, so that's how I evaluate expressions for a variable equals some number. All right, let's try another one. I encourage you guys to pause the video at this point and try this one on your own. So we are evaluating this expression when b is equal to negative 5. So I'm first going to rewrite the expression leaving parentheses anywhere I see my variable, b. So I'm going to leave my parentheses here. I'm going to leave parentheses here. Anywhere I see a b, I'm leaving some room. And instead of plugging in b, what this equality tells me is that instead of plugging in b, I can just plug in -5. It's easier to work with numbers and variables. So I'm going to plug in -5 anywhere a b would be. Now, order of operations says to do the exponent first. So -5 squared is 25, -5 times -5, and I'll carry everything else down. I like to do it step by step so that we are not missing any little things that, like a sign error or something. Okay, so at this point in PEMDAS, I want to do multiplication next, and I have multiplication right here. I'm multiplying -8 times -5, and the reason is because I have this parentheses right here, -8 times -5. And, because I substituted in, whenever I substitute something in, I want to make sure that there's parentheses there. And we can also look at it up here. Before we substituted, we had -8 times b. All right, so -8 times -5 is going to give us a positive 40. So I'm going to put a positive 40 down there. All right, now I just add from left to right. And I get 69. All right, so as I mentioned on the first slide, we can follow the same steps when we have 2 or more variables to substitute in for. So let's try an example where we have 2 variables that we need to substitute numbers in for. So evaluate this expression, -6x plus 7y, when x equals 3 and y equals -5. So anywhere I see a variable, I'm going to leave an open space. So -6, I'm going to do green parentheses for x. See, I'm just replacing x with the green parentheses, and I'll do the purple parentheses for y. Okay, and so what this is telling me is that x is the same thing as 3, so instead of writing x right here, I can write 3 instead. So that's going to be -6 times 3, and instead of writing y right here, I can write -5, because y is -5. Okay. So PEMDAS says, hey, let's go ahead and multiply first. So we have -6 times 3 is a -18, carry down the plus. A 7 times a -5 is a -35. And remember, when we have a plus and a minus directly next to each other, we can turn that into just a subtraction sign. So this becomes -18 minus 35. So what's -18 minus 35? Well, that's going to give us -53, and that's our answer there. -53. All right, let's try another one. We want to evaluate the expression when a equals -2 and c equals 6. And the expression in question is this one, 5 times c minus a. So I'm gonna let c be purple parentheses. So anywhere I see a c, I'm gonna replace it with purple parentheses. And the minus sign comes down because it was already there. And anywhere I see an a, I'm gonna replace that with green parentheses. So minus and then green parentheses. So in replace of c is the purple parentheses, in replacement of a is the green. And it says, hey, I can replace a with -2. So in here goes -2. And it says here, hey, I can replace c with 6. So in here goes 6. Now, I have a double negative here. From our integers unit, 2 negatives makes a positive, so I'm going to take care of that first. And so this becomes a positive. And then I can go ahead and multiply. 5 times 6 is 30. 30 plus 2 is 32, and that is my answer there. All right, let's try another one. Evaluate the expression when b equals 13 and c equals 7. So I'm going to do B in green, and I'm going to do C in 7, making sure I put my parentheses when I'm substituting. So my expression is C squared plus 5 parentheses. Now instead of B, I'm going to put parentheses 13 minus, and instead of C, I'm going to put parentheses 7. So I just replaced B with parentheses 13. I replaced C with parentheses 7. Still have that black parentheses on the outside. And now I can simplify. So order of operations, PEMDAS says do P first, anything in parentheses first. So I want to take care of the 13 minus 7 before I move on. And that's going to be 6. So, oops, and I forgot this C right here. This C is also a 7 squared. But I still want to do parentheses, so I'm going to carry everything else down, 7 squared plus 5, and then in parentheses, I'm going to evaluate this. 13 minus 7 is going to give us 6, and I didn't need to make the parenthesis that big. But this is where I'm at so far. The 13 minus 7 becomes 6 because parentheses comes before exponents. Now I want to take care of my exponents. That's next in PEMDAS. 7 squared becomes a 49. The plus sign comes down. The 5 comes down. 6 squared is 36. So now I have this. Now let's go ahead and do multiplication. That comes next in PEMDAS. So 5 times 36 is going to give us 180. So I carry down the 49, I carry down the plus, and I carry down the 180, and I can just add these guys at this point to give me 229, and that is my answer. Now let's see if we can extend this concept a little bit. What if I told you, let's do another example. What if I told you that I wanted you to evaluate 3x squared minus x at x equals a? Well, we apply the same logic that we did before when x was equal to a number. We just replace the x with whatever it equals. So if we're evaluating at x equals a, that means we're substituting an a anywhere we see an x, just like we substitute a number in anytime we saw an x before. So instead of x, I'm going to put in a anywhere I see an x. And then, you know, this really can't be simplified. I just have 3a squared minus a. And, you know, that's our answer, and that's okay. It's all right that it's not a number. We applied the same kind of logic here. It said, hey, you know, the rule of the game is this. You have an expression. I tell you to evaluate the expression at a given value for your variable. You plug that value in. Call it a day. Doesn't matter if the value is a number. Doesn't matter if it's a variable or a constant. We just apply the same logic here. So that is our answer. Alright, so when variables are in the numerator or denominator, we want to first simplify the numerator because it's like grouping, right? So the PEMDAS says, you know, parentheses is kind of the same thing as grouping. So we group the numerator and the denominator separately. So we simplify the numerator, simplify the denominator, and then we divide the numerator by denominator. So let's do some examples where we have to do this. Okay, so the first one is evaluate this expression right here when f equals 8 and g equals 3. So anywhere I see an f, I'm going to put an open parentheses and replace it with 8. And anywhere I see a g, I'm going to do an open parentheses and replace it with 3. All right, this is over 5. I got an f on the bottom, so I got 5 times 8 times g squared. All right, so that is that. All right, now I need to simplify the top. So PEMDAS says multiply the top. 6 times 8 is 48. Negative 4 times positive 3 is a negative 12. And then on the bottom, I want to do PEMDAS, right? Because the bottom is like its own group. The top is like its own group. You're doing PEMDAS within the group. So in the bottom group, PEMDAS says, hey, I want to do this exponent first, 3 squared. That's going to give us 9. So I have 5 times 8 times 9. Now, on top, if I simplify, all that's left to do is do 48 minus 12. I get 36 on top. And on bottom, all I have is multiplication. I have 5 times 8 times 9. So I'll just do that. 5 times 8 times 9 is going to give me 360. And I want to, you want to get in the habit of writing it as a fully simplified fraction. So if I divide top and bottom by 36, on top I get 1, on bottom I get 10, and this is fully simplified right here. Okay, so that is our answer, 1 over 10, yep. All right, let's try another one. We want to evaluate this expression when a is equal to 1/2. Okay, so anywhere I see an a, I'm going to just put an open parenthesis, squared minus 6, parenthesis, and I'm replacing 1/2 in there. Anywhere I see an a, I'm replacing it with 1/2. All right, so PEMDAS says, hey, I need to take care of this exponent first. So 1/2 squared, do you remember how we did that? Any number squared means we're multiplying it by itself. So 1/2 times 1/2, multiply straight across. 1 times 1 is 1, 2 times 2 is 4. So 1/2 squared is 1 over 4, so let me replace that. So now I have 8 times 1 over 4 minus 6 times 1 over 2. All right, now I just have multiplication. So 8 over 1 times 1 over 4, let's do some scratch work off to the side here. I can cross simplify if I want to first. So on the diagonals, 8 and 4 have a common factor of 4 to divide out. So 4 goes into itself once, 4 goes into 8 twice. 2 times 1 across is 2. 1 times 1 across is 1. 2 over 1 is just 2. So 8 times 1 over 4 is simply 2. Okay, that becomes 2. And then 6 times 1/2, well, again, cross simplify. 2 goes into itself once, 2 goes into 6 3 times. Multiply straight across to get 3 over 1, which is 3. All right, so this becomes minus 3. So 2 minus 3 is going to give us a final answer of -1. Okay. All right, let's try one more. So this is our expression. We want to evaluate 8x plus y over 4 minus xy squared, and we're going to let x equal -2, and we're going to let y equal 2. So anywhere I see an x, I'm going to put parentheses -2, right? That's what I'm subbing in for x here. So anywhere I see an x in my expression, I'm going to sub in with -2. Anywhere I see a y, I'm going to sub in with a +2. And this is going to be all over 4 minus x is -2, so put that there. Y is 2, and I'm squaring that last one right there. All right, now remember, I want to treat the numerator and denominator as separate entities. So in the numerator on top, I want to do multiplication first. That's the PEMDAS order. So I want to do 8 times -2 to give me a -16. I still have the +2. And on the bottom, the first thing I want to do is the 2 squared, right? And the 2 squared is going to give us 4. So this is 4 minus -2 times 4. And on the bottom, you should recognize that these double negatives can condense to a positive. On top, recognize that -16 plus 2 condenses to -14. So I have -14 on top, and on bottom, again, these two plus becomes these two minuses become a plus. So I have 4 plus 2 times 4. Okay, so doing PEMDAS on the bottom, I want to take care of this multiplication. 2 times 4 is 8, so I'm left with negative 14 over 4 plus 8, and that becomes 12 on bottom. So negative 14 divided by 12 can be simplified, right? If we divide top and bottom by 2, we get negative 7 over 1, or wait, sorry, negative 7 over 6, and that is our fully simplified answer right there. All right, let's do some word problems. The profit a ticket agent makes is represented by this expression, 95x plus 72y, where x represents the number of adult tickets sold, and y represents the number of child tickets sold. And then they tell us 40 adult tickets are sold and 15 child tickets are sold. How much profit does the ticket agent make? That's what we want to know. So the first sentence tells us what the profit is. Now that doesn't make much sense to us because we have variables. The profit is this. So the profit, I always like to just say what everything equals. The profit is equal to 95x plus 72y. Now x represents, okay, so let's write it here. X is adult tickets, the number of adult tickets, and y is the number of children's tickets. And they tell us that 40 adult tickets are sold. So x must equal 40. And they tell us that 15 child tickets are sold, so y must equal 15. All right, 15 child tickets. So now I can just replace x with 40 and y with 15 into my profit expression. So anywhere I see an x, I'm replacing with 40. So I have 95 times 40 plus 72. Anywhere I see a y, I'm replacing with 15. Okay, and then I can just multiply these guys. So 95 times 40, it's going to give us 3,800. And then 72 times 15 is 1,080. Okay, so adding these together, I get my profit is 4,880.